episode 245. Welcome to Data Skeptic, a podcast about data science and fake news from an algorithmic perspective. Here's your host, Kyle Polich.
Well, you're only going to hear that fake news intro a couple of more times here as the year winds down and we're getting ready for our next theme to kick off. In fact, today's episode really has nothing at all to do with fake news. Today begins a little bit of my coverage from recent interviews conducted at the NeurIPS conference 2018 in Montreal, Canada. My first interview from NeurIPS, I spoke with Bessega from Stradigi AI. She's the chief science officer there, and she told me about a project that her team's been working on using deep learning to read the standard alphabet of American Sign Language positions.
I'm Bessega. I'm the chief scientific officer at Stradigi AI.
And what does Stradigi AI do?
We are an AI solution provider, and what we do is we help enterprises and government to find solutions to optimize processes within their organizations. We want to transform the industry to a more efficient one.
And what brings you guys out to NeurIPS?
The main reason I have been coming to NeurIPS for several years because for a company like ours, it's very important the research aspect. We want to be always a state-of-the-art or create a state-of-the-art for different methods, different areas. So it's super important. We have 18 researchers assisting, attending to all the conferences. And the goal is when we go back to the office, brainstorm and find what of what we learn can be applied to our products.
Anything interesting that stands out so far you're excited to try out in that regard?
There are multiple things. I think that one thing that we're very interested in is how we can work more in an unsupervised manner. Right now, getting data, annotated data, is always a headache, especially in the area of natural language understanding. So there has been several very interesting talks about how we can leverage data, non-annotated data, and still using, for example, language models, being able to solve different tasks.
What sort of natural language generation tasks have you guys taken on?
We do a lot of them. So, for example, we do things that are more simple, like name entity recognition, that is recognize countries and people and companies or sentiment. But we also do things, for example, from different type of reports, get the key phrases, the drivers, but that maybe sounds not too complicated, but when you need to do that across several industries, what is a driver in one industry is a complete different thing in another industry. So we work on that. We also work in understand hierarchy within documents. When you have a big amount of documents and you want to know if modifying one of them can impact any other document that might be related with that one.
So there's a lot of people working on some of these common language tasks like sentiment.
Yes.
What's unique about Stradigi AI that people would want your solution?
Well, I think that the people who want our solution is not people that only want sentiment. So if you want somebody to do a small, one only task, probably we are not the right fit. What we do is we use sentiment within bigger projects to really help you to optimize things. For example, imagine you want to do forecasting in the stock market. We might use sentiment of news to do that. So it's not only about the small tasks here and there, it's how to put a lot of things together to create a product that can help your organization.
Are there any case studies you're able to share about ways in which you've helped organizations develop in that regard?
I can give generic examples. Mm-hmm. Okay, so some generic examples, we help, for example, in the transportation industry to find security issues when, for example, you have a self-driving vehicle and now you want to know if there is a pedestrian that will cross or is a pedestrian that will go in the opposite direction. Or you want to detect all kind of signs, you want to understand the scene and you want to categorize the different type of risks that you will have. That's an example. Another example is we have several projects in the financial industry associated with portfolio optimization, how we can, with the minimum risk possible, get the maximum profit using, as I was mentioned before, not only stock market like return data, but also more non-traditional sources of data. A lot of unstructured data that come from text. Maybe we haven't done it, but who knows, from videos. So all these things, so that's part of our expertise.
Yeah. Unstructured data brings a lot of challenges. Can you talk about some of the ways you facilitate that from technology and methodology and these things?
I think that unstructured data has two main challenges. One is how we can label that data. That is what we work with, why we try to work unsupervised. The second challenge is pretty much advanced and solved through deep learning, because in particular deep learning, the main goal of deep learning is find the right representation, is learn how to represent this unstructured data to be able to solve a task. So that part, we work with deep learning, with neural networks, to be able to get information from the data. Now, the part that is complex now is, what is this data that we're getting? Or in a lot of cases, what happened with our clients is that they have a lot of data, but it's not really well structured, well categorized. They don't even know exactly where it is or how it is. It's difficult, the process, from the moment that you talk with a client to the moment that you define a project, that I will say that might be 25% of the challenge. Only define the problem with the client. But we help them on that. So we have a team, it's our client transformation team, that they guide them through workshops on how we can make this happen.
Very neat. So I know one of the components of your presence here at NeurIPS is sort of a charitable AI for good type of thing. Can you tell me about it?
I want to say two things here. But first is that Stradigi AI, we want to give back, because we're getting a lot from being in this industry right now. It's a good moment. We're in Montreal, and we decided to use part of our time helping organizations. So we have a couple of AI for good initiatives. The first one is with the CHUM, with the hospital here in Montreal, the Montreal University Hospital. We're starting working with them to predict epileptic seizures. So the idea is how we can help to improve the well-being or the life quality of patients that suffer epilepsy and they cannot be treated through surgery or drugs. So how we can predict a seizure before it happens. So this is one of the things that we're starting doing. The second one is the one that we're presenting here at NeurIPS. The way it was born was very organic. So we needed to produce something for NeurIPS because we have this beautiful booth downstairs, and we cannot show anything from a client. So we decided, okay, let's do a contest within our company to see what our staff, our people wants to do. And we got 18 different proposals, we analyzed them, and at the end, the one that won was the American Sign Language detection. So when we started doing the project, we found some public data sets in the internet, but they were not very good. So we started contacting different deaf associations here in Montreal, and one of them was the Deaf Anglo Literacy Center. And they were super kind. We wanted two things from them. One is help us to produce more data because we needed the capturing video, different symbols so we can train our neural network. But the second thing that we were very concerned is that we don't want to be offensive with the deaf community in any way. So we wanted their validation. We were doing a learning game, but we wanted to make sure that the symbols were done in the proper way, that they don't feel that the fact that we were gamifying the experience was something that was affecting them in any way. So we work with them very closely in the user experience to make sure that was good. So we work on that. The game works pretty well. We decided as a retribution to them that for every person who plays now at NeurIPS during this week, we're going to donate $10 per person. So far, we have around 800 persons has already played. So our goal is $10,000 and for tomorrow, 3 p.m. So I think we're going to reach it.
Seems like it.
Yes.
I've held off so far because I wanted to make sure I came in with the right mind to ask good questions before I had the experience. So I'm going to go down after this and try.
Yes. Try
What will I experience when I go and start to play?
Well, I think that you will experience challenge and fun.
But what's the nature of the game? Yeah.
Okay. So the idea is we're using image and video understanding to understand the gestures of your hands. So basically, the experience of the game is 3 rounds. In each round, we show you a word, and we also show you the gestures that you should be doing with your hand. You need to do them in front of a camera, only your hand in front of a camera, and the camera will recognize the gesture. If you do it right, you get points, and also you get additional points if you do it faster. So it's a combination. Also in the score, because we were thinking also how to make fair the score too. In the score, we took into account because everybody can have different words. the complexity of the word is part of the score.
Ah, that makes sense. Yeah. Tell me a little bit about how you built the system. It seems like a big task to not only do image recognition, but there's a video component.
Yes, so we capture all the frames in the video. Okay, for every frame in the video, we're doing 2 tasks. The first task is doing a pose estimation because you need to detect the hand. Because the only thing that you want from that video is the hand of the person. So we're using a convolutional pose machine, is the name of the method. And with that, we're detecting all the joints in your hand. So all the joints for each one of the fingers, 21 different joints. With that, we're able to identify, yes, this is a hand. And in fact, we were starting using some state-of-the-art methods, but we're too slow because you need this to happen real time. So we modify the neural networks to make them real time. After that, after I have identified that you have a hand, at that point, I crop that area and we use a classifier. So that classifier, we try first with architectures that were very standard architectures like Inception before, pre-training ImageNet, and after fine-tuned with our system. Again, was a little slow, the inference. And we decided to create our own neural network. And we in fact benchmark against even a small neural network like MobileNet. And our benchmark is much better. So for example, much better, like 2% better. For example, Inception before, I think, is 97% accurate, and we're in 99% accurate. We use it, the neural network was designed by us, and then we also use our proprietary AutoML method to enhance, it's a differential neural architecture search to enhance it. So that's it. So we detect the hand, we do the convolutions, we classify, we tell, there was one more thing. So as we wanted to be very sure, because we needed to do it right for this event, we added a voting strategy. So we check 10 frames in your hand, and if 8 out of the 10 frames say that this is the letter, we say, yes, it is. So we try to confirm it to make sure that it's not that you just were moving the hand. And after we did all the UI, the UX, all that, and the process was around months and a half of work.
So if you're so fortunate, maybe working on a problem, you might have a binary classifier. Seems a lot easier than the multi-class problem you're working on. Can you talk a little bit about how many labels you're trying to detect and that sort of thing?
In this case, are 28. It's a 26 American alphabet, plus 1 for thumb up because we need to calibrate the game doing thumb up, and 1 for nothing, background, garbage.
Gotcha.
So there are 28 labels in total.
Makes sense. So you mentioned the accuracy overall around 99% or so?
99.03.
Very good. Does that vary by gesture? Are some harder to detect?
Yes, that's a very good question. So we have the confusion matrix. And in the confusion matrix, there is the M and the N that they are very similar. For those, the error is about, we had 400 samples in the test set. For those, 365 were good and 35 or 34 were bad. So it's around, let's say, 9% only for that letter. Because it's very similar. People in the podcast are not going to see it, but one is like this and the other one is on the finger like this.
Very close.
So it's very close. So what we did is that why we implemented the voting strategy, because the error is less than 10%. So if I take 8 out of 10, this is going to be canceled. And so far, hasn't failed.
Very cool. How have signing people respond, or have you had a chance to show it to any signing people and get their feedback?
Yes, we showed to the Deaf Anglo Literacy Center, and also here at NeurIPS, I think that 3-4 different persons who know sign language has come.
Oh, cool!
Because they were at the conference.
Yeah.
And all of them has said that they're pretty accurate. This is pretty accurate and good. Yes.
So are they on the leaderboard then for the game, I would assume?
Yeah, they're on the leaderboard. We clean the leaderboard every day to give a chance to everybody, yes, but...
All right, it's early, so maybe I've still got a shot to learn.
Yes, probably you are still in the leaderboard, yes. Tell
me a little bit about what's next. It seems like with this accuracy...
I want to mention something additional to the accuracy. One thing that we're very worried about, and I'm a member of the Montreal Ethics Meetup group, is ethics. So when we were coming to this conference, one of the things that I wanted to make sure that we were not doing is having any bias in the data. So, for example, that people from different ethnicities were all recognized. Because this is a very diverse and multicultural conference with 8,000 persons around the world. And I really want to make sure that everybody was included. Not only ethnicities, for example, long nails, short nails, rings in your hands, tattoos, all that. So we not only augmented the data set to make sure that we had samples for everything. We did that digitally. But also we went to several testing locations trying to capture different ethnicities, different type of nails. We even asked people, girls in our office, I need you tomorrow to paint your nails. to make sure, because inclusivity and non-bias is super important for us.
Absolutely. How big does your initial training data set of images get?
100,000 images. What was not super difficult to capture because we capture video. And from the video, we're at 30 frames per second. So every second that somebody, what we did is that we were recording everybody in video doing the thing. And after that, and we were telling them, okay, you need to do for 1 minute or for 10 seconds the symbol. And after that, we were cutting, annotating automatically. We didn't need to annotate manually each one of them.
Wow, that seems like a lot of work.
Well, yes, we tried to work as smart as possible.
Sure, yeah. Certain amount of automation you could do, I guess, because you have the timestamps of the video.
Yes, that's what we were doing.
We talked a little bit, I think, about the model. Do you build it from scratch or do you use some transfer learning?
In the first one, in the convolutional post machine, we started by a model that already exists, and we modify it to fit our real-time requirements. The second case, that is the classifier, that one we built it from scratch.
Gotcha. You'd mentioned something earlier I didn't quite capture. Was it differential neural search?
Yes. So neural architecture search. So that's basically, right now everybody say, okay, the future is do AutoML. AutoML is, the neural network is going to be generated by itself. The problem with that is that the search space, so imagine, and I put this as an example for people who is not necessarily in neural networks, when you have a lot of Lego blocks. And now you need to put them together to create a castle. So what will happen is that if you start randomly testing or doing all the possible combinations, this is going to be too large. So this is your search space. Your search space is all the combinations that you can do. So this is too much. So what we do is, instead of doing that, we take an architecture that was already created by one of our researchers, and there we only make small changes in the connection. So not us, the AutoML, using this technique, make small changes in the connections to optimize it. So instead of building everything from scratch, we optimize something that our researcher has done. And also, it's something about my philosophy. I think that neural networks are not random. When you put the layers in different positions, when you decide to do a skip connections, or you decide to put dropout, when you take that decision as a researcher, it's because you know why you're doing that. So think that a machine in a very random way is going to try to test all the possibilities and find an optimal result, I don't think is right. I think that what is right is have AutoML to help the researcher to, once he has already crafted something, let's make it better.
So with the accuracy you achieve, the project seems like it's off to a good start.
Yes.
What's next? How can this help the signing community?
Yes, so we haven't decided because we were doing, this was very fast. So once and a half, we were running to have it done for NeurIPS. Now that we're here, a lot of people have asked, can I contribute? There is a way that we can help. Are you going to open source this? And those are answers that I don't have, because all this week has been happening now. So when we come back to the office, we're going to need to take a decision if we as a company wants to continue the AI for Good initiative by ourselves, or if we prefer to open that at the community and not only contribute ourselves, but let the community do it.
Cool. Well, either way, I think it'll be interesting to watch how it all unfolds. How can people learn more about Stradigi AI and follow you guys online?
Well, we have a website, www.stradigi.ai. But yes, we're in Twitter, Facebook, we're in all social medias.
Awesome. Well, I'll put some of those in the show notes for people who want to follow up.
Okay.
Carolina, thank you so much for your time today.
It was my pleasure being with you, and your questions were great.
Thanks for listening to Data Skeptic, where the news may be fake, but the data doesn't lie. Show your support by getting a t-shirt at dataskeptic.com.